Hi everyone, this is Team 12. We're here to present our design solution for Design Project 4. This is Meimei Peng, and I will be summarizing the need of our client. So the client we were designing our device for is Ms.Liu, who was registered with SAS due to her severe joint pain caused by unknown reasons about her immune system. Due to her joint pain during her flare-ups of her condition, it results in her limited ability to use her fine motor skills, making it very difficult and painful to accomplish tasks as simple as opening a water bottle or a door or typing. Despite the physical pain she had to experience during the past 2 years, the failure of doing simple tasks was often depressing for her too. During the interview, she mentioned several times about the inconvenience she has to face because she was not able to open a water bottle. Therefore, we saw this as an emphasis of her needs and decided to design a device to help her with opening items, especially for water bottles. We believe that an efficient device to help her with simple but essential tasks can give her both physical and mental relief. At the same time, we hope that our design can help her to approach her goal of living a normal life as much as possible.
Hi, this is Evelyn Cudmore, and I'm going to be speaking to you about the proposed design solution. When approaching Ms.Liu's needs, we determined some main points we wanted to tackle. We knew the device would be intended for increasing her ability to open water bottles and turn doorknobs. We determined that making it purely mechanical would be beneficial because it would be simple, not require electronics or software, and could be much more lightweight and portable. Due to Ms.Liu's disability, she has limited fine motor skills, so we knew our design had to minimize the need for finger and joint use. We also didn't want to overcomplicate something as simple as opening a water bottle or a door, so a goal of ours was to maintain simplicity and convenience. Pictured on the right are some of our concepts, all of which revolved around a gripping mechanism and a paddle to apply torque to the device. The concept that we came to with Ms.Liu in mind was the donut clamp. On the right, you can see our initial sketch for the device, which involves a housing approximately the size and shape of a donut with many small sliding pieces inside. The pieces, backed by a strong compressive spring, can apply a grip to any round item placed in the center of the device. Each sliding piece has an angled upwards face, such that the horizontal component of any force applied to it will push the pieces outwards, causing the device to fit to the shape of the item pressed into it. The size can be adapted as the springs are compressed, making this device much more versatile to different water bottles, doorknobs, or even other objects like jars and lids. Once applied to the item, the device could be turned by a torquing mechanism such as a paddle, allowing for the item to be opened conveniently. The design has the potential to be lightweight because it's small, can be 3D printed from plastic, is hollow, and can fit on a keychain or in a backpack.
My name is Anusha, and I'm going to describe our first preliminary prototype and thought process behind our initial design. As you know, our goal is to help Ms.Liu open water bottles, and our initial CAD model was basically a scaled-down version of all the technical mechanisms behind our design. So our design consists of two main components, an outer frame and 8 sliding panels, although we only CAD'ed one panel for demonstration initially. We intended to demonstrate that each panel would be connected to a spring, which would then be secured to the outer frame of the device. Each panel would have its own compartment and track to ensure that it did not interfere or run into other panels when being used. The purpose of the sliding panels was to ensure that Ms.Liu could use different sized water bottles with our device. And after modeling this first prototype, we learned that we needed a mechanism such as a handle so that Ms.Liu would be able to use our device without exerting much force and without having to use her fingers that much. We also learned that we needed to consider how the bottle cap would be opened without the entire bottle turning when our device was used. In addition, we learned that we needed to consider a potential material to coat the pieces on the inside of our device with so that our internal mechanisms could efficiently grip objects and prevent any sliding. We also learned that we needed to consider how strong of a spring would be used in the device and how Ms.Liu would remove our device when she opened her water bottle. So overall, our preliminary design conveyed a general understanding of our ideas behind the sliding panels and how they would attach to the outer frame, but we learned lots of valid modifications that we can make to this prototype.
Hello, my name is Graham Buchan, and I will be talking about our final prototype and next steps of our design. Our high-fidelity prototype would be a completely mechanical device that will allow Ms.Liu to open a variety of water bottles and door handles. Starting from the top of the design, as seen in Figure 1, there is a rounded surface where the client will place their hand when applying the device. This surface differs from the original prototypes as it is designed to allow for an ergonomic grip with minimal hand movement required. Embedded within is now a fold-out handle which can be flipped open as seen in Figure 2. This allows for additional torque to be applied when using the device on objects with more resistance. Moving to Figure 3, we can see inside the body of the device. This is the gripping part of the device, which functions identically to the original prototype. The lid of the device, shown in Figure 4, also underwent some minor alterations, as a twist-to-lock mechanism was added. Figure 5 shows us the beveled edge design of the gripping pieces with the spring embedded in the back of the piece. This design, similar to all previous prototypes, allows for inserted objects to slide along the beveled edge and push the pieces to the outside, while the springs provide resistive pressure on the object being inserted. The gripping pieces will fit inside the body of the device the same as before, with the beveled edges all meeting around the center. In terms of building our final prototype, we'd have 3D printed all the required pieces, with a fair amount of infill to increase the durability of the device. To increase the gripping abilities of the device, we would have also glued some sort of rubber lining to the gripping pieces and inner layer. Overall, this design aligns with our original need statement as it provides Ms.Liu with a portable opening device that does not require any additional accessories, limits the movement of joints within the fingers and wrists, and is easy and comfortable to use. To test if our device meets the standards described by the need statement, we would perform measured tests on a variety of water bottles and door handles to evaluate the torque the device could produce. In summary, we believe that Ms.Liu would want our device as it provides a subtle yet practical way to regain the ability to open water bottles and doorknobs.